there's a couple of ways that you could tackle it. One way you could say, well, let me just add the non-fraction parts. You could say that 2 plus 3 is equal to 5. And then you could say that 4/7 plus 2/7 is equal to, well, 4/7 plus 2/7 is going to be equal to 6/7. Anyway, wait, how did I do that? How did I just only add the fraction parts or add the whole parts? But the way I did that is because 2 and 4/7 is the same thing as 2 plus 4/7. 2 and 4/7, same thing as 2 plus 4/7. And then plus 3 and 2/7 is the same thing as 3 plus 2/7. So all I did over here, 2 and 4/7 plus 3 and 2/7 is 2 plus 4/7 plus 3 plus 2/7. And you could swap the order in how this happens. So you could just switch the order and say this is going to be 2 plus 3, 2 plus 3 plus 4/7 plus 4/7 plus 2/7 plus 2/7. And what we just figured out was that 2 plus 3 is equal to 5, right over here, and that 4/7 plus 2/7 is equal to 6/7, just like that. Now let's do a more interesting example. Let's say that I have 3 and 3/5, 3 and 3/5 plus 5 and 4, 5 and 4/5. Now what is this going to be equal to? Well, if you do the same technique, if you add the 3 plus the 5, you're going to get 8. And then if you add the 3/5 plus 4/5, you would get 7/5. So you get 8 and 7/5. And this wouldn't be wrong. This is 8 and 7/5 if you add these two things together. But it's a little bit strange here because 7/5 is bigger than a whole. So to get a better sense of what number is really being represented here, I want to rewrite this. So 8 and 7/5, this is the same thing as 8 plus, instead of 7/5, we could say this is the same thing as 5/5, which is a whole, plus 2/5, plus 2/5. Now why is that interesting? Because 5/5, notice 5/5 plus 2/5, that's 7/5 right over there. Or you can consider 5/5 to be 1. So this is 8 plus 1, which is 9 and 2/5. 9 and 2/5. So all I did here, I added it the same way that I did the first problem a few seconds ago. But when I realized that this fraction part is greater than 1, I separated it into 1 and then a fraction that is less than 1. And that whole I was able to add to the 8 to get to 9. And then I would have 2/5 left over. 8 and 7/5, because 5/5 is a whole, is the same thing as 9 and 2/5. So if I wanted to write this in kind of a clearer way, I would say this is 9 and 2/5. 3 and 3/5 plus 5 and 4/5 is 9 and 2/5. And once again, you say, wait, 3 plus 5 is only 8. How did I get a 9? Well, that's because 3/5 plus 4/5 is greater than 1.
5 and 1/7 minus 2 and 3/7, and let's use stack form again. We're starting out with 5 and 1/7, so it goes on top, and 2 and 3/7 goes on the bottom. But when we try to subtract the fractions column, you'll see that we have a little problem. 1/7 is less than 3/7, so we can't subtract it without getting a negative number, which we'd really like to avoid. So what do we do now? Well, do you remember what you do in multi-digit subtraction when you have to subtract a bigger digit from a smaller one? Yep, you borrow or regroup from the column to the left. And we can do something really similar to that with mixed numbers. We can make the fraction part of a mixed number bigger by borrowing from the whole number part. In the video about adding mixed numbers, we learned that a mixed number with a fraction part that's improper is bad form, because you can simplify out a whole fraction and then add it to the whole number part. Well, we can do that process in reverse also. We can subtract out 1 as a whole fraction from the whole number part and add it to the fraction part to get an improper fraction. And even though that's considered bad form, it's okay because it's not our final answer. And it helps us subtract the fraction column without getting a negative fraction. In this example, we do that by changing the whole number part, 5, into 4 plus 1. and then changing 4 plus 1 into 4 plus 7 over 7. And finally, we can combine that 7 over 7 with the 1 over 7 to get 8 over 7. Now the fraction on top is big enough to subtract 3 over 7 from. 8 over 7 minus 3 over 7 is 5 over 7. And then we just need to subtract the whole number parts. The top whole number used to be 5, but we borrowed from it, so now it's 4. 4 minus 2 equals 2, so our answer is 2 5/7. Let's try another example to make sure you've got it. And let's make it a story problem this time. Suppose there's this guy who's a builder named Rob, and suppose he needs to fix something by subtracting the mixed number 1 5/8 from 6 1/8. Can he fix it? Yes, I can. Well, at least with the help of my trusty cat Richard. Where did that rascal run off to? Richard? Richard? Oh well. The first thing we need to do is put these in stacked form, with the number I'm taking away on the bottom. Then I need to subtract the fractions. But I notice that the fraction on top is less than the fraction on the bottom. So I need to make the fraction on top bigger by borrowing from the whole number part. I can replace the 6 with 5 plus 1, and I can replace 5 plus 1 with 5 plus 8 over 8 to get the whole fraction I need to add to the top fraction. 8 over 8 plus 1 over 8 is 9 over 8. So now I can subtract the fraction column because the fraction on top is bigger. 9 over 8 minus 5 over 8 is 4 over 8. And then I can subtract the whole numbers. 5 minus 1 is 4, so the answer is 4 4/8. Does that look right to you, Richard? You're right. 4/8 can simplify to 1/2. So my final answer is 4 1/2. Thanks for your help, Richard.
Making equivalent fractions. This is a must-have skill. With it, you will ace your fractions problems. If you're ready for this film, then you've used fraction strips before. Here's a whole one. Let's fold it to make 2 halves. This whole is in quarters. This is in sixths. This is in eighths. And this is in tenths. Let's colour up 1/2 of it. 1 part out of 2. And that's 2 parts out of 4. And 3 parts out of 6. 4 parts out of 8. And 5 parts out of 10. You can see these are all equivalent fractions. Notice that the denominator is 2 times its numerator for all these equivalent fractions of 1/2. And you could easily think of some more like this without using fraction strips. 10 over 20, 30 over 60, 50 over 100. I want you to take a note. The rule is equivalent fractions can only be made by multiplying or dividing. And whatever I do to the numerator, the top number, I've got to do to the denominator, the bottom number. Now let's go back. These equivalent fractions of 1/2 have bigger numbers, but we can see they all have the same size value. So we multiplied to get these equivalent fractions. Now let's think about that without the fraction strips. Here's 1/2. What do I multiply the numerator and the denominator by to get this equivalent fraction? 2. 1 times 2 is 2 and 2 times 2 is 4. I used a factor of 2 to make this equivalent fraction. You can see whatever I do to the top, I've got to do to the bottom. So if I use a factor of 3, I get this equivalent fraction. A factor of 4 gets me this equivalent fraction. And when I use 5, I get this equivalent fraction. You can see it in action here. Whatever I do to the top, I've got to do to the bottom. That's easy enough, isn't it? Okay then, so let's do some practice to make it stick before you hit the worksheets. 3 over 4, 3/4, 3/4. What if I make an equivalent fraction using a factor of 2? Whatever I do to the top, I've got to do to the bottom. 3 times 2 is 6, the new numerator, over 4 times 2 is 8, the new denominator. Or I could use 3. 3 times 3 is 9, over 4 times 3 is 12. I could use 5. 3 times 5 is 15, over 4 times 5 is 20. I can use any factor I choose to make an equivalent fraction, as long as I multiply both the numerator and the denominator by the same number, then I'm doing it right.